Welcome to day 2 of our sequences unit. All right, in this day 2, we are going to be looking at what we call the recursive formula. So our goal for today, given a sequence in recursive formula, you will be able to write out a list of the terms in the sequence. So let's go ahead, let's jump right in. So here we go, the recursive formula. So our recursive formula finds a term of a sequence by using another term in the sequence. Each term is defined as a function of its preceding terms. Each term is found by doing something to the terms immediately in front of that term. Okay, it is the number that you start with, but is not included in that list. Oops, we're missing that. So a sub 0 is the number that you start with, but is not included in that list. All right, so let's take a look here. So if we take a look, a sub 1, we learned from our lesson yesterday that this is just a way of saying that it is a function. It equals a sub n minus 1 plus 2. Well, if we take a look here, a sub n minus 1, well, this is just another function. Now, if we take a look, a sub 1, a sub n minus 1, so this is going to be the new term, is going to be equal to, well, this is going to be the old term plus 2. So for n greater than or equal to 1, and a sub 0 equals 4. So remember that a sub 0 is not included, but this is what we call the initial value. So this is the value that we start with, and we can plug in as our old value. So it is the initial value, and it is not part of the sequence. Okay, similarly, instead of having n and n minus 1, we could also have a sub n plus 1. Again, this is just a fancy way of saying that it's a function, equals a sub n. Okay, again, another function. But if we take a look, n plus 1 and n plus 1, that would be your new, equals your old, plus 2. Again, for n is greater than or equal to 1, and a sub 0 equals 4. So since n has to be greater than or equal to 1, a sub 0, well, 0 is less than 1, so it can't count. So this is just your initial value. All right, so let's go ahead and take a look here. So write out the first 3 terms in the sequence. A sub 0 equals the initial value and does not count. So here, we're going to go ahead and take a look. So a sub 1 equals the term before it, so your new, your old, plus 2. A sub 2 equals a sub 1 plus 2. A sub 3 equals a sub 2 plus 1. Okay, this might seem like a lot, but let's take a look at our first example and see if we can get it to make a little bit more sense. It says, write out the first 3 terms in the following sequence. A sub n plus 1 equals a sub n minus 5, for n is greater than or equal to 1, and a sub 0 equals 9. Now, n has to be greater than or equal to 1, and a sub 0, so this is a 0, so this doesn't count, but this is going to be your starting value. Okay, and then if we take a look here, we have a function and a function. So there's 2 functions here. So we have to figure out which is new and which is old. Well, this is going to be your new function. So your new function equals the old function minus 5. So let's go ahead and take a look here. So we want to find the first 3 terms. So we want to find a sub 1 equals. Well, we're going to take our old term. So our old term here is 9. So I'm going to take this 9, I'm going to plug it in. 9 minus 5. So let's go ahead. 9 minus 5 is 4. So now I'm going to find a sub 2. So what I have to do, a sub 2, the term before it is the 4. So I take this 4, I bring it down. So 4 minus 5, and we get negative 1. To find my third term, a sub 3, I take this negative 1, I bring it down. So negative 1 minus 5 gives me negative 6. So the first 3 terms in this sequence are 4, negative 1, and negative 6. So if you take a look, what we're doing is we're taking the 4, subtracting 5, we get negative 1. Subtract 5 again, we get negative 6. Subtract 5 again, the next one would be, that's it, negative 11. All right, so let's take a look at our next one. So if we take a look again, we have a sub n plus 1. We have a sub n, so we have two functions. So we have to write it down. So we have your new function equals 1/2 of the old function. Again, n has to be greater than or equal to 1. A sub 0 equals 4. So 0 is not greater than 1, so this is just our starting value. So let's take a look. So a sub 1 equals, so that's your new, so it's 1/2 times the old. So 1/2 times, and I'm going to take this 4, bring it straight down, and we get 4. So 1/2 times 4 is 2. To find my second value, I'm going to do 1/2, and I'm going to take this 2 and I'm going to bring it down. Okay, and 1/2 times 2, we get 1. And then a sub 3 equals 1/2 times the old, so I'm going to bring this 1 straight down. And 1/2 times 1 is just 1/2. So my sequence here is 2, 1, and 1/2. All right, let's take a look now at our next one. So a sub n equals a sub n minus 1 plus 3. So again, we have 1, 2 functions. So let's rewrite it as the new function and the old function. So here we're going to have our new number equals the old number plus 3. Okay, for n is greater than or equal to 1, and a sub 1 equals -2. Careful, n is greater than or equal to 1 and a sub 1. So look at this, they gave us our first term. So a sub 1 equals -2. So now we have to find a sub 2. Okay, so we're going to do new equals old plus 3. So I'm going to bring this straight down. We're going to go -2 and then plus 3. -2 plus 3 is going to give us a positive 1. So then I'm going to take my third term, a sub 3 equals, now I take my old term, I bring it right down. So 1 plus 3 equals 4. So my first 3 terms in this sequence are -2, 1, and 4. And we've got it. So this is your recursive formula. So this is written in a sub n and a sub n minus 1 form. What we're going to do now is we're going to continue practicing this. It might seem a little confusing, but the more we practice, the better we're going to get. But now let's take a look to see what happens when instead of in that form, we put it in function form. So again, this is recursive notation in function form. So find a term of a sequence by using the prior term in the sequence, just like we did before. List the first 4 terms in this sequence. F of x equals f of x minus 1 minus 4, when f of 1 equals 5. So just like before, if you take a look here, we have 1 function, we have 2 functions. So if we take a look, f of x minus 1, so this is our new, equals the old minus 4. So let's go ahead and try it. So they already give us our f of 1, so that's our first term. So f of 1 equals 5. So now if I want to find f of 2, I have to do old minus 4. So I'm going to bring this 5 down. It's going to be 5 minus 4, which gives us 1. To find f of 3, I take my old, which is going to be 1, and I subtract 4, which gives me -3. To find f of 4, my fourth term, I take the old number, I bring it down, -3 minus 4, we get -7. So my 4 numbers are 5, 1, -3, and -7. All right, let's go ahead and try a couple more. So if f of 1 equals 3, and f of n equals 3 times f of n minus 1 plus 6, find f of 4. Okay, so let's go ahead. Let's rewrite this with our new and our old. So f of n minus 1. So this is going to be your new number equals 3 times your old number plus 6. So we want to find f of 4. But we can't find 4 unless we find 3, 2, and 1 beforehand, because each term grows off of the one before it. So here we have f of 1 equals 3. So now if I want to find f of 2, that's going to be 3 times the old plus 6. So 3, I bring this 3 down. and plus 6. So 3 times 3 is 9, plus 6 is 15. Now to find f of 3, it's going to be 3 times the old, so 3 times I bring the 15 down and I put it in, plus 6. So 3 times 15 is 45, plus 6, 51. Now to find f of 4, I go 3 times the old, I bring that down, 51, plus 6. So 3 times 51 plus 6 is 159. So f of 4 equals 159. And we have our answer. So let's just make sure, if we want to make sure we did it right, we take a look. So here's our 15. We want to make sure there's 15 here. We take a look, your old term here was 51, and the 51 goes into the next function here, and then you finally get your final answer. So you can see it's just you're carrying it down. All right, let's go ahead and try another one. So number 3, if f of 1 equals 16 and f of n equals f of n minus 1 squared plus 1, find f of 3. I'm going to go ahead and rewrite this. So f of n, here's my first function, so this is going to be my new function, equals f of n minus 1, so this is going to be my old function, squared plus 1. So let's go ahead and let's try this out. So f of 1 equals 16. So they gave us the first one. F of 2. So I'm going to take the old, so I'm going to take the 16, bring it down, and add 1. And the calculator help me out here. So 16 squared plus 1, 257. So to find f of 3, I'm going to go ahead and I'm bringing my old function, putting it down, and adding 1. So I'm going to go 257 squared plus 1, and we get 66,050. So f of 3 equals 66050. And we have our final answer. All right, so now that we know how to list out the terms, let's practice a multiple choice question. Which recursively defined function represents the sequence 3, 7, 15, 31? All right, so let's go ahead and let's try it out. So here, f of 1 equals 3, f of 1 equals 3, f of 1 equals 3, f of 1 equals 3. They all have the first term as 3, okay, so we can't rule anything out. So let's take a look at the first one here. So we have f of n plus 1 equals 2 raised to the f of n plus 3. So this is going to be your new equals 2 raised to the old number plus 3. Okay, well, we already know that 3 is the first term. So now I can go ahead. So my new number is going to be 2 raised to the 3 plus 3. So let's take a look. So 2 raised to the 3, that's the 3, plus 3. Oops, but I got to bring that down. It's no longer a power, so I'm going to try that again. 2 raised to the 3. Now I have to use my over arrow, and now I'm going to go plus 3. I get 11. Okay, 11 is not my second number, so this is not going to work, and the answer is not choice 1. So let's go ahead and try choice 2. So f of 1 equals 3. F of n equals 2 raised to the f of n minus 1. So let's take a look. So that means the new, so that's the new, equals 2 raised to the old minus 1. So we already have the old as 3. So let's take a look. So your new number would be 2 raised to the 3 minus 1. So let's try that out. 2 raised to the 3 over minus 1. Oh, look at that. We get 7. Let's try one more. So new equals 2 raised to the 7 minus 1. So 2 raised to the 7 minus 1. 127. Nope, we wanted 15. So that one's not going to work. All right, so we cross that one off. All right, and let's go ahead then and try number 3. So we have our new equals 2 times the old plus 1. And if we take a look here, this one will indeed work out. All right, I'd like you to go ahead, try number 5 on your own, and I'll see you all in class tomorrow.